The last thing with exponents is putting all the rules together to simplify different problems. So we've multiplied, we've divided, we've raised exponents to exponents, we've had negative exponents, we've had zero exponents. What you're mainly going to see, and this is where some of the difficulty comes in, is all these things will be combined into a single problem. And the biggest thing that you have to pay attention to is what you actually have for each problem. And most of this stuff does in fact look the same, so it's very easy to get confused from one thing to the other and not realize what you actually need to do and what you don't need to do. So for instance, we'll take this problem. And the first thing that you should see when you look at this problem is that you've got a couple different things to do. You've got some multiplication up top, and since it's a fraction, you have division amongst the whole thing. With exponents, it's always best if you think of things in terms of each individual operation. These problems really are the sum of all their parts. So if you do each thing individually, that works out to be what your final answer is. Now, when you have more than one thing to do, especially when you're given a fraction like this, the easiest way to approach it is to think of simplifying everything on the top, simplifying everything on the bottom, and then simplifying the whole entire fraction with whatever you have. In this case, when we look up at the top, we can actually simplify it. There's multiplication going on here. On the bottom, there's nothing to simplify. So once we simplify the top, the next thing is to get our final answer by simplifying everything. So when you look up on top, you do have two different things that you can do. You have your coefficients, and then you have your variables. And these are going to be two different operations. Since we're multiplying, the exponents need to get added and the coefficients get multiplied. So we have 3 times 6 is going to give us 18. And we have x times x squared, which means 1 plus 2x to the third. Now on the bottom, there was nothing to do, so we still got the 10x to the 8. Now when we're looking at this, what we have is, again, 18 over 10. That's something we can simplify. And x to the third over x to the 8. So this still works out to be two different operations and two different things that we have to do. Once we get through with these two parts, whatever answer that we're left with is going to be our final answer. There's not going to be anything left to do. So again, we've gotten out of the habit of thinking of divide this because that's not going to divide out, and most of these things won't. It will, however, simplify. 2 is going to go into 18 9 times, and it's going to go into 10 5 times. The last thing to check is there anything that goes into 9 and 5? Well, if you start off with a smaller number, there's just 5. So the only thing that goes into 5 is 1 and 5. Well, since 5 doesn't go into 9, we know we've reduced that all the way down. Now we look here at the variables. We've got the same base, so these can be divided. We start with the biggest. 8 minus 3 gives me 5, and since there's more x's on the bottom, I'm going to have x to the 5th on the bottom. And that's all there is to that problem. It looks a lot harder than it really is, but once you start breaking it down and think of it in terms of individual parts, it goes pretty easy. The next problem will look like this. And sometimes you'll see things written differently. Sometimes you'll see parentheses like what we had in the first one, and that's showing multiplication. Sometimes you're going to see just a single dot, and that also means multiplication. Don't let these two confuse you. Up top here and down here is the same thing. Now what's different in this problem is we do have simplifying on the bottom, and we have a lot more simplifying up on top. We've got a parentheses that has an exponent to the outside. So the first thing we have is an exponent raised to an exponent. Then we have multiplication. We can't multiply first. Think order of operations. They apply to everything. You've always got to do parentheses and exponents before multiplication, meaning we need to take care of this before we can multiply it with the x squared. So to do this, keep in mind over here that we have to remember that that coefficient does in fact have a 1 for an exponent. So what we're going to end up with is 3 squared and x to the 8. And again, that's coming from 4 times 2. Then it's still multiplied by x squared. And on the bottom, I'm going to go ahead and simplify this. 5 times 2 is 10. And I've got x times x, which is x squared. Now the top can still be simplified even more. Don't forget we do have to simplify numbers with exponents. So 3 squared is going to give me 9, and I've got 8 plus 2 gives me 10. So this is x to the 10. On the bottom, I've got 10x squared still. It's really easy when you're doing these problems and there's multiplications. There's exponents raised to exponents. There's multiplying numbers but not exponents to get confused. So take your time when you go through these and think, okay, I've got an exponent raised to an exponent. The rule is multiplication. I've got multiplication of exponents, and the rule for that is addition. That's how I came up with the 10. Now, when we try simplifying the whole entire thing, 9 over 10, there's nothing we can do with that. I've got 10 minus 2, which is going to give me 8. There's more x's on top, so I've got x to the 8 on top. With these problems, they can keep putting more and more and more stuff in there, but really it still comes down to the same rules of multiplying, dividing, raising exponents to exponents, negative exponents, and zero exponents. There's nothing more really that they can put in there. So as long as you can break everything down to those rules, it becomes pretty easy. Now here's the next problem. We'll throw a negative exponent in on the bottom, and we've got multiplication up top. So since there's no coefficient here, we've got 4, we've got 2, plus 2 gives me x to the 4th. Then I've got 7x to the negative 5. You might be tempted to try to move this up to the top, and that's going to give you multiplication, and you can do it that way, but you really should get comfortable with just dividing these out, because most of the time, again, the negative is going to take care of itself. Since 4 is bigger, it's going to go 4 minus a minus 5. Now the double negative turns that directly into a positive. Make sure that you actually write it out when you're dividing with negative exponents, because otherwise it's very easy to just do 4 minus 5 and get a negative 1, and that becomes wrong. So 4 plus 5 is 9, so what I end up with is 4. Since there was more x's on top, it's x to the 9, and I still have the 7 on the bottom. Just like that, the negative exponent took care of itself, and I didn't have to do anything with it. Just by dividing out the problem, it took care of itself. So if you can take these problems and go slow and break them down into smaller parts, they become much easier, and you're a lot less likely to make a mistake.